You are watching Tutor.
For today's lesson, let us learn how to find the quotient of a given polynomial expression using synthetic division. So the first thing you will do here is to express the dividend in its standard form by arranging its terms in descending order. Okay? Then let us equate the divisor to 0, which is now x plus 2 equals 0. Now let us solve for the value of x by additive inverse. Now we are going to add up negative 2 to both sides of the equation so that we can now cancel out that positive 2 on the left side of the equation, and x now is equal to negative 2. Now we are ready to pick all the numerical coefficients and constant, then write it on the first row. Okay, so let's start with positive 2. We have negative 3. Now next, if you can see here, there is no x squared. Therefore, we are going to put here 0. And then next, for that x, we have positive 1. Then here, we have negative 1. Now, we will put the divisor here as negative 2. Okay? Then put a bar. Bring down the first numerical coefficient, which is 2. Now, the next process is to multiply negative 2 times positive 2 will give us negative 4. Then we will add this up. We have negative 7. Then let's do the process again. Negative 7 times negative 2, we will get positive 14. Positive 14 plus 0, we will have positive 14. Multiplying positive 14 by negative 2, we'll get negative 28. Now, adding this up, we will have here negative 27. Next, negative 27 times negative 2, we'll have positive 54. Negative 1 plus 54, we'll get positive 53. Okay, so here, this is now the so-called remainder. On this part, we have here the constant. On this part, we have the linear part. Here, we have the quadratic part. And here, we have the cubic part or term. Okay, so to finalize this one, we will just pick the numerical coefficient and the variables. So we will have here 2x cubed minus 7x squared plus 14x minus 27. Now with the remainder, we are going to pick 53 as our numerator, and then our divisor will be the divisor given in the expression. So we have x plus 2. Therefore, dividing now 2x to the fourth minus 3x cubed plus x minus 1 divided by x plus 2, we will have 2x cubed minus 7x squared plus 14x minus 27 plus 53 over x plus 2. Now, what if we are asked to find 4 other roots of the polynomials? Just like this one, we are going to find for other roots of the polynomials with 2x plus 1 as one of the factors. Okay, so the first thing we will do is to check if our given polynomial is already in its standard form. Now, what we are going to do here is to rearrange if it is not yet in its standard form. So let us rearrange. Okay. Then check now if your exponent or the exponent of the given polynomial is already in its descending order. Okay, so that's correct now. Now, the next thing we will do is to equate our 2x plus 1 to 0, the divisor, so that we will be able to get the first divisor in our synthetic division. Okay, next step is to solve for the value of x by additive inverse. So we'll fix here, or we'll put here 2x plus 1 equals 0. Then we'll add the additive inverse of positive 1, which is negative 1, to both sides of the equation. Okay, so having this now, we'll be canceling that positive 1 plus negative 1 because this will become 0. Therefore, we have here 2x equals negative 1. Okay, so we're not yet done because we still have here 2 as numerical coefficient of x. So what we are going to do next is to divide both sides of the equation by 2. Okay, now we can now cancel 2 over 2, which is now equal to 1. Therefore, x is equal to negative 1 half. Now, this negative 1 half will be the first divisor that will be used in finding other roots of the given polynomials. To determine the possible roots to be tested as our divisor, so we'll be using the Rational Root Theorem, wherein we are going to divide P over Q. Our P here are the factors of the constant over Q, the factors of the leading coefficient. So we are going to factor out positive 8. We have plus minus 8 and plus minus 1. We also have plus minus 4 and plus minus 2. And the factors of our negative 2 will be plus minus 1 and plus minus 2. So dividing now plus minus 8 over plus minus 1, we got plus minus 8. Plus minus 1 over plus minus 1, we got plus minus 1. Plus minus 4 over plus minus 1, we got plus minus 4. Plus minus 2 over plus minus 1, we got plus minus 2. Plus minus 8 over plus minus 2, we got plus minus 4. Plus minus 1 over plus minus 2, we got plus minus 1 half. Plus minus 4 over plus minus 2, we got plus minus 2. And plus minus 2 over plus minus 2, we got plus minus 1. So these are now the values to be tested. But this is not a guarantee that all of these are factors of the given or roots of the given polynomial expression. So let's start. We are now ready to pick all the numerical coefficients and constant, then write it on the first row. So we have here negative 2, positive 13, negative 21, positive 2, and positive 8. Then from this divisor, we got negative 1 half as our first root divisor. So we bring down negative 2 for the first process. And then we are going to multiply now negative 1 half by negative 2. We got positive 1. Add 13 and 1. We got positive 14. Multiplying it again by negative 1 half. We got negative 7. Adding up negative 21 and negative 7. We got negative 28. Negative 28 times negative 1 half, we got positive 14. 14 plus 2, we got 16. 16 times negative 1 half, we got negative 8. And adding up positive 8 and negative 8, we got 0. So it only means that from our roots, we consider negative 1 half as one of the roots of the given polynomial expression. Okay, now let's test our 8. So let's take for example, we have here positive 8 as our divisor. Now let's do the first process. Let us bring down negative 2, multiply it to our divisor positive 8. We have negative 16. Adding them up, we got negative 2. Negative 2 times positive 8, we got negative 16. Adding this up, we got negative 44. Multiplying negative 44 by 8, we got negative 352. Adding up positive 16 and negative 352, we got negative 336. Now let us multiply negative 336 by 8. We got negative 2688. Adding this up, 0 plus negative 2688, we have negative 2688 as remainder. So since we have here a remainder, it only means that our 8 must be rejected. Okay? So let us proceed with the next one. Let us try positive 1 as divisor. Okay, let's have here positive 1. Do the same process. Bring down negative 2. Multiply negative 2 by 1. We get negative 2. Adding up positive 14 and negative 2, we got positive 12. Multiplying 12 by 1, we got positive 12. Adding up negative 28 and positive 12, we got negative 16. Now multiplying negative 16 by 1, we got negative 16. And adding up positive 16 and negative 16, we got 0. Now since this is 0, we now consider positive 1 as one of the roots of the given polynomial expression. Okay, so we can now proceed with the next one. Let's try positive 2. Let's have here positive 2. Let us repeat the process. Bring down negative 2 here. Multiply negative 2 by positive 2. We got negative 4. Add up positive 12 and negative 4. We got positive 8. 8 times 2, we got positive 16. Now adding up negative 16 and positive 16, we got 0. Therefore, we consider positive 2 as one of the roots of the given polynomial expression. Now, we still have linear term here. So this is our constant and this is our linear term. Therefore, we can still have one root to test. So let's make use of that 4. Positive 4. Okay, so bring down again. Negative 2 here. Multiply negative 2 by 4. We'll have here negative 8. Adding up positive 8 and negative 8, we got 0. Therefore, your positive 4 is also included as one of the roots of the given polynomial expression. So to sum it up, our other roots, other than the negative 1/2, which is already given, we have also the roots 1, 2, and 4, or positive 1, positive 2, and positive 4. So that's how easy we use the synthetic division in finding out other roots of a given polynomial expression.
Like and subscribe. Tutor Med. Happy learning!